us examine the Calculate the Number of Printed Shades section. Let's return to the sticker example from the previous video. One user on the website ordered stickers 50 by 50 millimeters, another 150 by 50 millimeters, and a third 300 by 200 millimeters. When printing these stickers on a plotter, the printing company typically calculates the cost based on area, that is, in square centimeters, and the price is formed based on this value. The problem with area-based price calculation arises when stickers are printed on shades, for example using offset or digital sheet-fed printing presses. In this case, when setting the sticker sizes and quantity, it is not possible to determine in advance exactly how these sizes and quantities will be placed on print shades and how many shades will be needed to fulfill the order. Here is how it works in practice. The stickers are placed on print shades. If the user orders a small print run, then by configuring the system here, for example by specifying the minimum print area as one shade, the system will not allow the user to place an order if it does not cover at least one print shade. But if the user orders a larger quantity, a situation may arise where two print shades are fully used, but the third shade is only partially filled by less than 1/4. At the same time, the actual production costs are the same for all three shades. Paper is consumed for the full format, a full shade pass is performed on the digital press, and a full click charge is applied for the third shade, despite the fact that it is barely used. The price is calculated based on area. Accordingly, we calculate the full area for the first and second shades, and for the third shade, the calculation will only reflect the small printed portion. As a result, the printing company incurs a loss on the partially used third shades. It is in such a case that the Calculate the Number of Printed Shades feature helps us. Let us set the print zone of an SRA3 shade as 450 by 320 millimeters. Product bleeds or bleeds are the technical margins that will be cut off from the finished product, but must be taken into account when placing the layout on the print sheet. When the user selects, for example, a format of 50 by 50 millimeters, this is the so-called finished size, the size of the product after trimming. However, during print preparation, the system must automatically add bleeds to this format, since they take up additional sheet area and are required for the correct post-press processing. The user generally does not need to know or see this technical detail. They order a product of 50 by 50 millimeters, but a larger size is printed so that the excess can be trimmed off each side. To demonstrate this, we will set an unrealistically large bleed 10 millimeters. As a result, the actual size of the product on the print sheet will be 70 by 70 millimeters, and the area 4,900 square millimeters instead of 2,500 square millimeters. This is important to consider because bleeds increase the area taken up on the sheet, which means they affect the final cost, even though the user only sees the finished product size. Let us enable and save. Note the change in the price section. The price for a product with variable area was previously shown per square millimeter, since the product size was specified in millimeters. Now it is shown as price per shade. That is, when the Calculate the Number of Printed Shades feature is enabled, the price is calculated based on the number of print shades. For convenience, let us disable quantity dependency on print area. Save. The price per one SRA3 print sheet is set to €1. Let's go to the website and take a look. 10 stickers 50 by 50 millimeters, actually 70 by 70 millimeters, since we added bleeds to the product, fit onto one print sheet, and the cost of the print run is €1. If we increase the sticker size to 100 by 100 millimeters, they no longer fit on one print sheet, and some are placed on a second sheet. The print run cost becomes €2. Increase the size to 150 by 150 millimeters. The stickers will be spread across 5 sheets, and the print run cost will be €5. We can print on 5 sheets both 150 by 150 millimeters and 200 by 200 millimeters stickers. The user will benefit from ordering a larger size, and the printing company will not incur additional costs. In other words, the system automatically calculates the required number of sheets to print products with a variable size, and the calculation is based on the cost per sheet. Let us return to the settings and enable dependency of product quantity from sheet count. With quantity dependency on print area, we could not print less than the minimum area values specified here. Likewise, with product quantity dependency on number of sheets, we cannot print fewer than, for example, 2 sheets or more than, say, 100 sheets with a step of 1. Let's save and check on the website. Given the bleed setting, 24 stickers of size 50 by 50 millimeters fit on one print sheet. Despite this, the minimum print run is automatically set to 48 units because the minimum sheet count was set to 2 sheets. Change the size to 100 by 100 millimeters. The minimum print run in sheets is 2 sheets, which corresponds to 12 stickers of size 100 by 100 millimeters. Thus, we protect the printing company from losses related to the user setting an overly small product size and print run. You can flexibly manage product parameters, define its size, link it to quantity and area, as well as split the total print run across sheets and perform detailed sheet-level cost calculation. Use all the features of the VentumPrint platform to calculate product costs.